Let us start with today's topic is the intensity of gravitational field. What do you mean by the intensity of gravitational field? The gravitational field intensity due to a mass m, due to this small mass m is equal to the force experienced by this mass placed at a fixed point, and provided that the presence of other masses does not affect the presence of external gravitational field, the other masses are not affecting its presence, and the force between these two, that is the force per unit mass, is the gravitational field intensity. For this, let us consider that let m be the mass of planet and m is body placed at point P at distance capital R from M. Now you know the gravitational force F is equal to Gmm by R square. This is the force. And according to the definition, the gravitational field intensity E is equal to F by M. So F is Gmm by R square and divide by mass. Put here in this equation Gmm by R square into M. This M will cancel out. The electric field, the gravitational field intensity becomes Gm by R square. And you also know this is the value of acceleration due to gravity also. Now what is the nature of this electric field, the gravitational field intensity? The nature is this is of vector form, because this intensity is having the same direction as that of force, and we can write it as E is equal to Gm by R square. Now what is the effect on the value of gravitational field intensity if we changes the value of R? This is having the inverse relation. This E is inversely proportional to R square. Hence when you will increase the value of R, the value of E will decrease. This E is a vector quantity, so you will put the vector sign also. This E will decrease, and hence if the value of R is very large, that is infinity, it means if you are putting here infinity, then the value of E is equal to 1 upon infinity, and that is 0. This is the important result for this one. This is case 1, and you can also have case 2. For case 2, you can have, if the body is moving, this free mass is moving freely and having an acceleration A. The acceleration A under the gravitational force F. You know from Newton's second law of motion, F is equal to ma. This A is equal to F by m, and these two equations, here you have the value of E, that is Gm by R square, or you can say F by m, and acceleration is also F by m. From these two equations, equation 1 and equation 2, from these two equations you can equate the value, and you can have that the gravitational field intensity is equal to the acceleration produced under the gravitational force. You can also write it as equal to the acceleration due to gravity. So you can write it as equal to the acceleration due to gravity. You have calculated the formula for G in the last class, that is Gm by R square, and similar value is for E. So you can manage this relation. All the points are important. You can recall these points. Now, the most important topic is the gravitational potential energy, GPE. The gravitational potential energy. This is the another most important question. What do you understand by the gravitational potential energy? This definition I have written. Before the definition, you understand this diagram, what to do and what is the gravitational potential energy. This is Earth, and Earth is considered to be the perfect sphere of radius capital R, and the body is of mass m initially was placed at infinity. When we start moving this body is entering in the gravitational pull of earth, and at one instant the body is at point A, and the distance of this point A from the center of earth is x at this position, and at this position the force at point A is F is equal to G by x square, and we further move this body toward in the gravitational pull of earth, and the body reaches at point B. Here this OB is equal to this AB is x. You have moved this through a very small distance x. In moving the body in and while entering the body against the gravitational attraction, what happens? The body is experiencing some force and the work has to be done. This work has to be done, and this work done, that suppose this is the very small work done, because you are considering this a very small distance. This small work done is equal to F into the small displacement traveled by this body. Put the value of this force, this is G by x square into dx. Further, this body is again moved to point P. Now this point P is at a distance small r from the center of the earth. Now you have to calculate the energy of this body at point P, which is at a distance r from the center of the earth. Now from this expression, what you can assume about the gravitational potential energy. Dear students, now you can say the gravitational potential energy is the amount of work done, because when you are moving the body, some work has to be done. This is the amount of work done on a body of mass m when the body is brought from infinity to the point in the gravitational field of earth. This is the gravitational field of another body, it may be. So now read the definition. I think it is more clear to you. It is defined as the energy associated with the body due to its position in the gravitational field, whether it is at infinity or at point A or at point P. This is the energy associated due to the position where in the field of another body. The another body here is earth. And how it can be calculated? It is measured by the amount of work done in bringing the body from infinity to a given point P in the gravitational field of the other body. Other body is here earth. So let us consider earth to be a perfect sphere, and the force at point A is gmm by x square. When you move it through a small distance, then work done at B, sorry, work done at B, that is with a small distance from A to B. F into dx, this value. For calculating for total work done, what you will have to do? You have to move the object from infinity to this point P, and at point P the value is R. So you will integrate this work done, that is from infinity to the position R, G mm by x square into dx. Here this term is a constant, you take it outside the integration, and this work done after integration is equal to G m m integration infinity to r 1 by x square into dx. Integration, you can solve it as integration of 1 by x square. This is x raised to power minus 2 dx. You know how to solve this. Then add in the power 1 x minus 2 plus 1 divided by the value. This is minus 1. So this is minus 1 by x. So you can directly write here the value that is 1 by x. You can write here this is equal to g m m into minus 1 by x, and the units are infinity to r. First of all, put the values of the limits g m m upper limit minus 1 by r minus lower limit minus 1 by infinity. 1 by infinity is 0. So this value is g m m into minus 1 by r. This work done is equal to minus g m m by r, and this work done is equivalent to the potential energy, that is the gravitational potential energy minus g m m by r. This relation is very important relation. And one more thing, students, this value of gravitational potential energy is inversely proportional to r, but when you will increase the r, the value of u will increase. This is the most important point. Why this is increasing? Because the value is 0. If you are not considering the minus sign, then the value is approaching near 0. But the value is negative, then the value is becoming or going towards the 0. And finally, at r equal to infinity, the value of u becomes 0. This is the maximum value of potential energy, that is 0, because it is moving from negative to 0. This increase is from negative to 0. Note down these points. Now the next subpart, the gravitational potential. What is the gravitational potential? It is the potential at a point that is associated with again the position, but it is the work done per unit mass. The work done associated with the unit mass with the position in the gravitational field of earth. You know the value that the potential is equal to work done by mass. The work done is W, m is mass. This work done is equivalent to the you can say gravitational potential energy. This is a scalar quantity, mass is a scalar quantity, so the gravitational potential V is a scalar quantity. The SI unit of V becomes, from the expression you can see, this is joule per kilogram, and in CGS unit is erg per gram. You can calculate the dimensional formula according to this value. And the one subpart is the gravitational potential at a point on earth, the gravitational potential. You know the value of work done, put the value of work done, that is minus gmm by r, which is equivalent to the gravitational potential energy, and divide by mass. So W is divided by mass when you are getting the relation minus gm by r square. So you can easily calculate the potential at the surface of earth, which is equal to minus gm by r. Now we can ask the question, what is the relation between the electric potential and electric potential energy? From here you can calculate this relation. The gravitational potential energy is equal to gravitational potential into mass. The value of gravitational potential is minus gm by r into mass, and you get the relation for the gravitational potential energy easily. With this, the topic of gravitational potential is completed. Now with one example, we will resume the lecture. Next question is, at a point above the surface of Earth, the gravitational potential is given, that is minus 5.12 into 10 raised to power 7 joule per kg, and the value of acceleration due to gravity is 6.4 meter per second square. The radius is 6400 kilometer, and calculate the height of this point above the Earth's surface. If you imagine the diagram, what was the diagram? This is Earth, this was capital R, and this point P, this distance was small r, and this is H. Okay, this R is given to you. This R you have to find this H. This R is the combination of H and R. First of all, for the solution, write the parameters given to you. The V is equal to minus 5.12 into 10 raised to power 7 joule per kg. R is given to you. G is given to you. You know the formula for the potential. This is minus Gm by R. And also you know the formula for G, because this V and G is given to you in terms of these two values. You can divide 1 and 2 and you have the relation V by G is equal to minus R. This V is known to you, this G is known to you, and you have to find this R. Adjust this minus sign of R here, and now you can put the value minus of this sign, and V is minus 5.12 into 10 raised to power 7. Don't make the mistake here that minus sign is given here, but you will also put this minus sign in the formula as well. 6.4, the R comes out to be 8000 kilometer, but this R is the combination of this H and this R, but you have to calculate only the height above the surface of Earth. So for calculating the height above the surface of Earth, you can put the formula and you can find H from here. This H is equal to R minus capital R. This R is you have calculated, this is 8000, and this capital R is 6400 kilometer. Now the height above the surface of Earth comes out to be 1600 kilometer. So this kind of examples you can try